All right, today we're going to track the evolution of a truly life-saving idea. It's a fascinating story, really, about how a super complex defense concept got distilled down step by step into something, well, something radically simple and accessible for everyone.
But first, we have to understand the problem. You see, in some conflict zones, a new and pretty terrifying type of weapon is being used, and it's targeting civilian places like schools and hospitals. The scary part? The usual defenses, things like radio jammers, are completely powerless against it.
So, what makes these drones such a unique challenge? Well, they're controlled by a physical cable, a fiber optic cable that's literally as thin as a hair. That physical connection means, you guessed it, you can't jam them with radio signals. And since they're tethered for power and data, they can just hover indefinitely, just waiting for the right moment to attack.
So that's the core question, isn't it? If you can't jam it and you can barely even see the control line, how in the world do you stop it? This is the exact puzzle that active grid defense was created to solve.
Okay, so let's dive into their first big idea. This was version 1, and it was all about proving a pretty radical concept. Could you actually detect and disable that tiny fiber optic cable directly? And the concept, honestly, was brilliant. I want you to picture a giant, high-tech spider's web. It uses a scientific property called capacitance to basically feel for that fiber. As soon as it detects contact, bam, it sends a tiny, high-voltage pulse down the exact wire that was touched. That pulse just melts the fiber's coating, and the drone is instantly disabled. The key takeaway? The physics totally work. But, while the science was solid, the reality on the ground was, well, it was complicated. We're talking over 23,000 Czech koruna. That's about $1,000 for just a small 5 by 5 meter area. And you had to manage 100 separate wires. The installation took 4 hours. It wasn't practical for the very people who needed it most, like schools or refugee camps. Okay, now we get to the first major aha moment. This was the breakthrough. The team suddenly realized they didn't have to protect the sky above a target. They just needed to protect the border around it. And that simple shift in thinking, well, it changed absolutely everything. I mean, this was a fundamental pivot in strategy. Instead of a complex web designed to catch things falling from the sky, version 2 became more like an invisible electric fence. It used the exact same detection physics as before, but it applied them in a much more efficient, linear way. And the results were, well, they were dramatic. The cost? More than cut in half. The number of complex sensor chips, it dropped from 25 all the way down to just 2. And the installation time was cut by 75%. Suddenly, for the very first time, protecting an entire school perimeter actually became economically possible. But even though V2 was a massive leap forward, it still wasn't a tool for just anyone. You still needed to install posts, you had to carefully tension the wires, and you needed a team that had some technical skills. The journey to making this truly simple and accessible, it wasn't over yet. And this next part, this is where the whole idea goes from being a clever innovation to a full-blown revolution. The new goal became radical simplification. The question was, how do you make this so easy that literally anyone, anywhere could set it up in just a few minutes? I mean, this timeline just says it all, doesn't it? We went from a 23,000 koruna project that took 4 hours to install all the way down to a system costing around 2,400 koruna that you can set up in 2 minutes. All the complexity was just systematically stripped away, piece by piece, until only the core, essential function was left. So what was the answer? It was to embed a single wire into a peel and stick adhesive ribbon. That's it. The entire system, all that complexity with posts and tensioners and multiple sensors, it was all distilled down into what is essentially a roll of defensive tape. And the installation process? It becomes almost laughably simple. You wipe the surface clean, you peel off the backing, you stick the ribbon on, and then you plug it into the little control box. Seriously, it's designed to be as simple as putting up a string of Christmas lights. And that's the real punchline right there. 2 minutes. 0 tools required. Suddenly, protection like this isn't just for experts or big, well-funded organizations anymore. Now it's something a family could use to protect their own apartment window. Now, to really grasp the sheer impact of this, let's put it into context for a second. A professional, legacy counter-drone system, the kind of thing an airport might use, can cost over 30 million koruna. Okay, now compare that to the cost for the most robust, premium version of this V3 ribbon concept. We're talking 3 layers of redundancy for extra safety. It's around 7,200 kuruna. We are talking thousands of times cheaper. It's a completely different world. And look, when you scale this up to protect, say, a 1 kilometer perimeter, the difference is just stark. The V3 ribbon isn't just way cheaper than radar or lasers, it's even cheaper and faster to install than its own predecessor, the V2 fence. This really does create an entirely new category of accessible defense. Okay, but let's talk about what is, for me, maybe the most important part of this entire story. This project isn't really about creating a product to sell, it's about advancing a whole philosophy of accessible, open source defense. The core idea here is to maximize impact, not profit. By making the designs completely open source, it means anyone who needs this protection can literally build it themselves. And just as important, anyone with a good idea can help improve it. It's a totally transparent, community-driven way to solve a really deadly problem. And get this, even the proposed business model is built around this exact philosophy. The idea is pretty simple. Commercial sales to, say, an airport or a big company would directly subsidize sending these systems at cost to conflict zones and developing countries. So the people who can afford it help pay for the people who desperately need it. There's a quote from the project that just captures the spirit of this perfectly. It says, "This is a concept seeking a community." Think about that. This isn't a finished product looking for customers, it's a powerful idea looking for collaborators to help make it a reality. And really, that's where this story is right now. We've seen the journey from a super complex web to a simple, life-saving ribbon. It just shows the incredible power of relentless simplification. We know the science works, the economics are undeniable, so the final and most important question is the one you see right here. Who will build it?